All right, we're back. Happy Thursday. Here we go. How's everyone doing? Oh, my lights are off. There we go. All right, let's get started. We're thinking about entities today, about like how to compose some common entities. There's a particular case that we're kind of interested in, but we're going to talk just kind of more about some structural game stuff too. Like, I always envision this game as like pausable real time, but I'm wondering if we'd be better off doing like turn-based or something. I kind of thought pausable real time by default because of FTL. Cybrus gaming of the development kind, exactly. How's it going? How are you doing this fine day? We're not going to answer the turn-based. When aren't we thinking about entities? Well, we're not thinking about the ECS system. Hopefully that's good. Depending on whether or not we need to add a dynamic buffer, but we're gonna talk that out. We're thinking more about, what are the common kinds of entities that we have. Maybe we need to go back to maybe we need to do some diagramming. Okay, we can get rid of this. Get rid of this. Let's group this. Structure of an entity. So this is like an entity in the abstract. Where it's like we have an entity. It has an ID. It has an archetype. It's associated with it. The archetype is a set of components. This isn't quite exactly how it looks, but it's basically it's an ID, the type. I guess this actually isn't super accurate, but let's put that aside for now. We also have a component diagram. No, this isn't what we want. What we want to think about is actually some of the entities that we're going to need. And then we'll go from there. So we need to think about the kinds of components that we would have for this. So let's say something like we're always going to have an entity ID. So we can always just start with that. We have position entities. I guess these aren't cards, these are groups. So we have index. So we have index, we have version. Together, this makes an entity ID. So we have like, and we also have things like a vector 3i value. This would be like our position. Oh, you can't group things that just consist of one thing, huh? Okay, so in that case, we would just have a position. The position is only one thing. It only has one value. So position's like another component that we'd have. We know that we'd have like a direction. But a direction and a position don't describe movement. They just describe like orientation. Let's try to line these up. It's weirdly hard to line up the cards in this system. Kind of fascinating. Because it wants to snap everywhere. You can't really get it to do this correctly. I guess if we do it like that, there we go. Like that. So we have like an entity ID, position, a direction. Maybe we don't bother with this. Maybe we have this as a separate diagram. So maybe instead of this, we have like, so we put this to the side, or this is like a blown up version of it, and then we just add a card that's like entity ID. Mainly the two kinds of creations of entities that I want to talk about today are like crew members, like people that run around and do stuff, and ships, which are like the backdrops and scenes of like, they're almost the main characters of the game, the ships. So they're like pretty complex entities. So an entity ID looks like this. This is like the more complex visualization of it. I kind of want like a way to relate these two, but so let's start forming things. So like I want to think about these two things together. The ships and the crew, because the crew obviously move around the ship. So a crew member would be like, so a crew member has all of these things at least, so we can at least start there. Let's just copy these. Don't really need this stuff. Maybe I want to keep some of this stuff. Kind of describes like how the process works. Move this over. But I want like an actual list of components. So maybe we take this, put this over here as like a list of components. This is like an archetype diagram. Maybe we move this to a new diagram. Rename this. Get rid of this one. We can just list out our components, our components here. It'd be cool if I could do a group for a single thing, but it doesn't seem like I can do that. Cybrus, since it's isometric, would a crew member have both a grid position and a world position? That's one of the questions we need to answer. And then is this obsidian? How do you have this kind of layout? It looks useful. Yeah, these are known as canvases, and they're super useful. Like you can do, like this is an early system diagram I mocked up, and it's really cool because you can have cards, you can have groups, You can define relationships between them, so you can have flow between them, which is pretty cool. You can do some pretty wild stuff. You can add cards, notes. So instead of just a blank card, the card could be a note to another page. It's pretty cool. You can also add media or you can add a web page itself, and the web page is pretty wild. Like if I add the Godot docs to this as a web page, it's not just like a picture of a website. It's like the actual website itself. Like it's interactive. It's like kind of wild. Pretty cool that you can do this kind of stuff. Really great for research and descriptions of things. How you can do this kind of thing. If you want to graph things like that, yeah, try it. Try it, Cyberus. Obsidian's free, as far as I can tell. There's some, paid for features that you don't need, but hey, Fox Shadow, this doesn't look anything like FTL. I know. We're heading that direction. We're diagramming some stuff out. This was the structure of an entity. I wanted to just kind of mock up some different entities and think about the structure of them. And I'm kind of weighing some different things. Like I'm back into the debate on possible real time versus turn based, because it would really change the way we structure this, I think. And Cybers is mentioning that it's isometric. So like, are we going to have grid positions and world positions? And I was thinking about that yesterday. Like, and the only real difference to do that, the reason to do that would be like, if we have like a float 3 positions, which is like represents your like progress towards a new grid position. It's a tempting way to do it. I mean, we could just have the float position and just round it to find your grid position, but that's not really what we want to do. We want like a transactional process for moving things from one point on the grid to the other. It's FTL inspired. Yeah, there you go. Diagrams and flowcharts and cards. Oh my. Fox Shadow, your devlog yesterday was so awesome. The one you posted here. This is so good. I talked about it a little bit. But this dealio, we don't have any sound, but like this is so awesome. Like the shadow does such good work here, communicating the Z level. Like it's incredible how good this is. I love that. It does so much work just having that little offset shadow. And there's a few other little touches like offsetting the ship icon itself off the center as well. It's pretty wild. How do you transition from planetary flight to star flight? Is there like a button, or is it just like if you go high enough, it like takes you back to the stellar flight? Like if you just keep going up until you're like off screen, does that then like load the stellar map back up or something? Or is there going to be a button? Because I think it'd be cool if you could just elevate yourself back into space. That's so good. Yeah, you did a really great job on that. You ended up with a surprisingly simple solution, which is always like the best solution, right? So we can delete this. This will be like our components. Component pool. I don't know. It's our component pool. This is all the components we have so far defined. Not a card. So so we got an entity ID, a position, and a direction. So it's kind of weird. Some of these components would be optional. So I like kind of don't want to just dig into this too much. You hit max altitude, you get placed back into the solar system. Yeah, exactly how I described it. That's so good. The OG game was that way. You could accidentally leave the planet when flying around if you weren't careful with your vertical thruster. Yeah, I think you do a good job of visually indicating if that's likely to happen, because it seems like you would approach the edge of the screen if you did. So, more as just an experiment or as an idea. Not an idea, but like, let's start by mocking up the crew member. So this could be a crew member, crew member entity. Crew member entity would have an ID. All entities have an ID. We're going to do this. We're just going to include this. It's implied, but we're going to include it just a crew entity. I don't know. So we have an ID, a position, a direction. We'd want to have another card here that's like be like its crew member. It's like or like member of. We'd want like member of. This would be like a reference to like what ship. Well, I guess it could be a reference to a faction too. It could be different than like a ship. What's the word for like? Wait, or what? Like, how would you refer to like a sailor and their ship? Like, how would you refer to that relationship? It could be called a posting or a station. I feel like a station would mean something else for us. Oh, a company. The company is referred to as as a term for all officers and enlisted personnel on a ship. Okay, so we could refer to the ship's company as like a list of other entities. So we could do that for the ship. So let's also start defining the ship entity. Let's do this because this is like the main relationship in the game is the relationship between the crew and the ship. So let's think about that. So we can a ship also has all of these components. Put these in here, group them together. Call this a ship entity. You spent some time clamping the camera to indicate the max height. If the camera followed the ship directly, you wouldn't realize you were gaining height. Yeah, exactly. I think you did a great job with that. It would just look like you were going north. Yeah. So a ship would have a company. It would have a company component. And that would describe basically everyone who belongs to the ship. I guess we call this posting. Posting is like what you're assigned to, like, which I guess is different than station. Station would be like I man the weapons system. So we might have something like that too. We're gonna have a large number of components really quickly. That would be for like if you have assigned stations. You'd also probably have a division. So like, are you an engineer? Are you a command officer? Are you like a medical officer? So you'd probably have a division. We're going to need to improve this organization. So posting is like whether like what ship or uh, base or planet or whatever, like what are you posted to? Your station, well, okay, let's do this the other way. Your division would be like, I'm a red shirt or a yellow shirt or a blue shirt or whatever. I don't love how easily the alignment gets messed up here. Station. So we could call this group assignments. These are like your assignments. How do I grab that? Why wouldn't you call it the crew instead of company? You missed that. Well, crew is going to be like, I don't know. Crew is the word I was going to just use for a member of the crew. Like I was going to is crew, can crew be used singular? Yeah, but in noun form is it singular? Crew is a collective noun. Yeah, you're right. Crew. So this is probably crew member. It's probably crew member. Have this describe the crew. The crew would be a list. We're going to get to this. We're going to get to the case of the list of entities or the list of things. We need to think about this. Remember, crewmate. Crewmate is good. Yeah, that's shorter. Crewmate. So we're always going to have an entity ID, obviously. We'll have our assignments, which is like our posting, our division, our station. Also rank. I think Fox mentioned rank. Rank would be good. Because we're kind of following a very Star Trek like paramilitary kind of structure here. That's how this is going to work. Okay, you're part of the group. Be in the group. How do I make you part of the group? Okay, you are part of the group. How do I... There you go. Roster is good. I especially like roster. Ooh, roster. We'll see. You called them crew members in your game and then assigned them roles, which have specific stations. Yeah, you went back and forth on what names to use for what. Yeah, that's all over the place. But this stuff is kind of like, these are easy. The main things I'm interested in, and the things I'm doing these because these are easy to get a hold on. There's a thing that is more important and way more complicated that we need to tackle. Which is like the blocks on a ship. So the blocks on the ship are like the individual segments. So like here's a block. This is like a floor block in a way of speaking. Here's a wall. This wall belongs to the same block if I just lay it out. So a block might have a floor or wall, or might have a floor and a door, or it's actually possible for it to just be a wall, but I haven't coded that in as a possibility yet. The auto tiler just enforces that all wall segments have floors. But if it was like the bottom, if it was like a downwardly curved piece and it was at like the bottom of the ship, it might just be the wall section, no floor. So there's this concept of the block. And this is the really hard thing. I know we were just talking about crew, but like the block is the thing, is like this, to me, this is the stickiest thing, because like something could be in a block. Like let's just make a room. So things could be in a block. A door could be in a block. You know, a crew member could be in a block. A control console could be in a block. Cargo could be in a block. A fire could be in a block, you know. A block has atmosphere. I might not calculate the block's atmosphere individually. I might go by room instead of block. So a block is in a compartment or room, or it may be. A block may be in a compartment. So like all of these blocks are in a compartment. These blocks aren't, because these blocks are the walls. These walls are the boundaries between compartments, so I don't actually give them membership of that compartment. We will need to be able to capture boundaries between these different rooms, but we're going to need some complex stuff to for handling the flow of oxygen between rooms, as if like doors are opened and closed or like walls are blown off. So we have this thing called the block, and a ship has a volumetric grid of blocks. And so the big question, the like $1 million question, is, are the blocks entities? It's a big question. The tempting thing is to say no. Block is not an entity. Well then, okay, so a block isn't an entity. A block only has meaning as part of a structure, like a spaceship or a starbase or something like that. Okay, then how do you process a block if it's not an entity? If you can't query for it, and you can't go through all of them, well then it's a field. That means a block is a component on a ship, but is it just one component? No, that's insane. So instead of having a block be just a single component on a ship, all of the blocks should be a component on a ship, right? Okay. Well, how big is that component then? It's enormous. You don't want to do that. Components have all of their data stored in place, with the entity. And components determine, an entity's chunk utilization is determined by its largest component. So components must be small. So we can't do that. So what do? Well, a common thing to do in an entity component system, in this case, if you want to have a list of things stored outside the chunk associated with an entity, is a thing called a dynamic buffer. Actually, it doesn't have to be dynamic. It could just be a buffer. You have a buffer, and so the entity has a reference to this buffer, and you keep all of this memory stored in this buffer outside of the chunk. It's cool. Kind of thrashes your cache utilization a little bit, maybe. Fixes chunk utilization because then it's not stored in the chunk. But like now, whenever you load an entity, if you process, here's the trade-off. So if you are processing a ship and you don't care about the dynamic buffer, like you're doing something else, like you're doing a transform system or something like that, and you're just moving the ship around and you don't care about the buffer, great, you've saved a bunch of time and memory and cache. Your cache utilization is good because you don't have this block buffer on the chunk with the ship or whichever entity you're talking about. So that's probably better, because if we try to store blocks by entity, or if we try to store blocks as entities, we can't associate a block with another entity in such a way that we could query for it unless we achieve entities as components. But we don't do that. We don't do entities as components because our list of components is static. Our list of components is defined at compile time. We don't do entities as components. We wanted to, but that's like would require a whole different system or structure to do. So we're very much headed in the dynamic buffers. Like blocks are buffered on an entity, because you can do a bunch of stuff that way. You can do stuff like, if this is a volumetric grid, you can do position as index. So you can have their X, Y, Z position become their index in the buffer. And that saves you, a whole vector 3, which is great when you're talking about, in this case, our maximum, had OBS in focus. That's a mistake. So for this thing, we have a grid. I think we have 5 or 6. 1, 2, 3, 4, 5, 6. We have 6 layers. I think we might switch to 5, but we have 5 or 6 layers that are 15 by 15 grids. So that's like a pretty decent number, whatever that is. Let's assume they're 15 by 15. They might actually be bigger than that. And then we say it's like 5 by 5 or 5 tall. That's like 1,000 blocks. If 1,000 blocks each had a vector 3, that's 96. That's 100,000 bits that you don't need to store per block, per block composition. Like, I don't know, it's just a good thing. So there's a bunch of stuff, whereas if we had blocks as entities, one, we couldn't process them by ship. We would have to process all of them. And blocks are often going to want to reference their neighbor. A block is very often going to be like, what does the block to the left of me look like? What does the block to the right of me look like? What does the block above me look like? Where if they're entities, that kind of entity-to-entity referencing is very bad. It's occasionally within the cache, but it usually just destroys any amount of linear in-order processing that you have going. So long story short, I think we need to implement dynamic buffers. So I guess I lied when I said our entity component system was done. Probably going to need dynamic buffers. Or just buffers. They don't need to be dynamic. They could be. And so we have to figure out some things about that. Because, yeah, a buffer, depending on how we index into the buffer, I'm tempted to just do x plus y times size of x plus z times size of y kind of deal, which definitely improves the data locality. It's not like Morton. It's not like we could do Z order stuff. We could do like Morton encoding to like maybe pack them in tighter. But I think I did a comparison early on and looked at like how bad it would be, and I think the best thing to do would be just a simple flattened XYZ deal like this. Oh, like, where did I put it? I thought we had an entity that described it. Oh yeah, ships. So here, this is like the ship component. This is stupid. This isn't something we're going to have. But you just do the flattened array indexed into by like this. That's probably going to be the best thing. It allows us to easily look up neighboring blocks quickly. And all the other things I described. I don't want to describe them all again. Oof is right, Cyberus, but still. There's a lot of trade-offs to make. But I think there's a very strong argument for a buffer. So I guess we need to think about how to make a buffer. Then we can go back to kind of how to structure our entities. So a buffer, our buffer might end up looking a lot like our chunk. Let's say buffer. Let's say buffer, and then let's open up our chunk. So a buffer, I don't think we want the buffer to be chunk-based. I don't think so. I don't think there's a strong argument for doing that. I could be wrong. I don't think there is. Buffers don't, I don't think buffers need this kind of memory indirection thing of storing everything as bytes and then casting it back. Because we know what a buffer is. Like if we're storing a buffer on an entity, we know explicitly what type it is. We know that it's a block buffer. Or, I don't know, we probably have a crew buffer. Actually, we probably don't have a crew buffer on the ship. That's probably a component tag or component on the individual crew mates. But yeah, maybe it is also a buffer on, maybe it's an entity buffer on the ship. So the ship has a list of all the entity IDs that consist of its crew. And it can just iterate through its crew that way. I mean, that's, again, it would be better if a crew could just have a ship and a ship component, or it would be better if a ship could have a crew component. What am I trying to say? It would be better if we could query based on specific ships and crew members. Like it would be very good if like we could query for all crew members that belong to a specific ship. But again, then we're getting back to entities as components, and we're not doing that. So we're going to do the next best thing, which is probably buffers. It'd be pretty cool if we had entities as components, but I think if we were doing that, that would be like we'd be going off the deep end into like rewriting this significantly. And when I wrote this, I did not see the way forward for that. So yeah, so maybe we do something like we have a memory buffer, and then if you want to read the buffer, you just load the span. Maybe that's overcomplicated. Maybe it should just be an array. You load it once, and then you just operate on it. Is it better to use C#? It is not. I mean, I don't know what you're saying better in the context of, but in the context of an entity component system, we'd be better off in like C++ or something. Okay, so here's our block struct. This is like, so a block has a set of forms. A block does not need a position because a block doesn't. A block is going to encode its position on the buffer using its index into the buffer. What else is a block going to need to know? Probably fairly little. Probably its room, if it has a room that it belongs to. I don't know. That's the one thing where it would be nice if they were entities, because we could add only the information that we actually needed. So if there were blocks that didn't belong to a compartment, we just wouldn't need to include the compartment component. But if we have blocks as fields of a buffer, then we need all of the values that a block could potentially hold. We need all of those to be just on the block. So I guess we're paying for it in that way. But yeah. Hey, Maxim. You were here around 1 month ago? Okay. Then when you arrived, we did not have an entity component system, and now we do. So we have a process for uh, creating entities, setting components, adding components, removing components, destroying entities, recycling entities. We also have a process for, so now we can just have, so a system can say, you know, give me all the entities with this set of components. It can also say, give me all these entities with this component, and without these components. So you can specify what entities you want to process, and then we have a way of iterating over the query, which is really efficient, where we just use spans. So you basically say, all right, here, the query is basically like, all right, here are all the entities that you want, and then you can just say, all right, the directions are the span for this and the span for this. This is read only, this is read write. And then we're just going to update in order all of the positions by its direction value. So yeah, we got some fancy stuff here in entity component system land, but now we're thinking about how to build some of the entities that we actually need in the game. Like the ship is probably the most complicated entity, and there's going to be a handful of them flying around at any one time. So we need a good way for those. And right now we're just thinking about how to structure or how to organize the structure of a ship in terms of how we're storing it. And I think we're heading in the direction of having a buffer of all of the blocks, which are the pieces of the ship, rather than trying to have blocks as entities. That's kind of what we're doing. So I think we've made some great progress in a month. You know, we got our whole entity component system put together, which was, you know, C# is not the best language to be doing that in, but I don't know enough about, I'm not comfortable enough in C++ to do that sort of thing. So we're not doing that. We had other options too, but this was the option that seemed like the best combination of like fast prototyping and like decent performance as far as what we could do for this. We ended up with an okay system for the entity component systems. We have a chunk-based system that uses memory and span. It's pretty efficient. We have queries. So a buffer. So let's look at a buffer. So buffer should probably, so if a buffer is a struct, we're passing it around by value. We could do it where a buffer is a class, and then that class holds on to a memory and can give out spans. Oh, it's a lot of work in 1 month. But you think ECS is not that important? It only becomes important when you make large. Correct me if I'm wrong. Yeah, you're generally right. So the reason we ended up doing that is we basically, so we're in Godot, you know, we've got our scene tree. I thought a lot about how I wanted to do this game, and this game is very much a simulation game. Like it's got, you know, there might be 4, 5, 6 ships that are all simulating. The crews are running around, power's going up, power's going down. You know, there's a fire on like 3 of them. Like there's all sorts of simulation stuff going on, but maybe you can only see one of those ships. Maybe only one of those ships is visible because it's your ship and you're focused on like putting out a fire. Like if you're only ever going to see 1 or 2 ships at a time, but you're simulating all of this stuff going on, I kind of wanted to move all of the game data and simulation stuff out of the scene tree and into a separate world. And I ended up settling on like a C# game data land that will manage all of the game data stuff, and then we just have to synchronize the small portion of it that needs to be rendered or interacted with. So, you know, we might only have like a 1/6 of the game entities, or far less probably even. We'd have a fraction of the entities actually being, you know, synced or coupled with nodes. So I just wanted a lightweight way of simulating the game, and this seemed like the best way to do it. We picked ECS not because we need the performance, but because that's just how I wanted to organize the game objects. I didn't want to make a more traditional object-oriented system for that. So from an organizational standpoint, I just preferred ECS. But yeah, we aren't. I don't know if we're ever going to hit the performance needs. Um, but it's one of those things, if we do, it's going to be a lot easier to optimize this than if we made this horrible web of references object-oriented thing where we had like a bespoke class or object for every kind of entity in the game. Or God forbid, we got into like some deep inheritance issues. I know you can do composition with like object-oriented, but this seemed cleaner. It seemed more lightweight, so we're kind of getting into it and just going with that. But yeah, so buffers. So we need to structure a dynamic buffer. The dynamic buffer is going to be... The dynamic buffer itself is a component. Okay. So it needs to be stored in a chunk. A chunk is in-place memory, so when you operate on it... So I guess a buffer could be a struct because we're not actually passing the buffer around. We're operating in place most of the time because we use spans for everything. So yeah, the buffer can be a struct. So let's do the thing we always do, which is make everything a read-only record struct just for fun. So a buffer is going to have... So here's the real question. Well, okay, here's the one argument for not making buffer a struct. If we use memory and span for this, to simplify the amount of copying, we don't do that. But it's probably better if the buffer just has a reference to an array, honestly, somewhere. It's probably better. Or a list if we want a dynamic buffer. Like, it's obviously not as fancy as our memory span based chunk system, but like if we do the memory span thing, the buffer is going to need to clean itself up when it's no longer referenced because someone's going to need to own that memory. Whereas if we just use an array or a list, it's like the garbage collector will handle it and we don't have to think about it. And it's like, yeah, we pay the indirection, but we only pay the indirection once when we get the reference to the array. Like each time we process it, we only pay for it once. Right? Well, I guess that's not strictly true in terms of how you iterate over the array. Depending on what you're doing to everything in the array. The nice thing about span is that you can do all of the operations in place. There's no memory copying back and forth. That's kind of tempting. Where if we were doing Well, good luck. Maybe next time in a month you'll check back. Yeah, no worries. Thank you. I appreciate you stopping by, Maxim. I hope everything's doing good with you. We'll keep struggling here. Have a happy holidays, etc., etc. I appreciate you stopping by. It's kind of a quiet time right now, so I appreciate anyone who's taken time out of the busy season here to hang out with us. All right. So let's do the easy part. The easy part is just adding the buffer. Well, I guess it can't be a just a generic buffer, huh? It needs to, well, We could do this a number of different ways, but I feel like we're going to want to define a buffer for every single thing that needs to be buffered. So it's not like you don't just have a buffer component. You'd have like a block buffer. Let's call it that. Let's say the block buffer. Block buffer is 8. And a block is our word for like a segment of the ship. Someone's calling me. Who this is? Sounds work related. I'll deal with that in a couple hours. Yeah, so we have a block buffer. Let's go into the component types. So this isn't going to be a block. This is going to be a block buffer. Unless we just want a thing for block.forms. Maybe we make the block a public static class or something like that. No, because the block is what's in the block buffer. Right. So the block is the thing that's in the block buffer, but the block itself is not a component. The block buffer is the component. As confusing as that is. And then so this isn't just a buffer. We need to change this to block buffer. Well, let's do this correctly, because I feel like if I tell this to refactor, it'll also rename the file for me. Is that how this works? Where's my refactor, rename, block buffer? Cool. Then we can go into component types and we can define a block buffer. One second. Almost tripped and died coming back to my desk. I have like a weird standing mat that has like these slippery curves on it. You almost just saw me crash into the green screen and go tumbling down. It would have been great content, if not much else. Oh, this is in a weird, of course it's in a weird namespace. At some point I'm going to figure out how to define the default namespace. Change the name of my solution or something. Probably have an ECS folder that would probably make it easier. Oh, we're not trying to make a class, we're just trying to make a folder. ECS directory. Put the components in there. The system's in there. Put a bunch of this junk in there. All of this, right? Everything except the game. So not the utility, not the game. I have an entity manager class? When did I make that? Oh, it literally does nothing. Okay. We have all the commands set up directly on the world, on the game world. Which is maybe not the best thing, but I think it's fine. You can get rid of search and result. Because the search and result classes we just turned into the query class, the single query class. So you, except you, and you all go into ECS. All right, cool. That simplifies things a little bit. So we make a new flags. Oops. There we go. So if we go back to our diagram here, ship like crew roster. Go with that for now. Try to avoid having components whose names are like 4-letter words. I know I have rank down here, but Might just call it roster instead of crew roster. We're going to have a block buffer. More fundamentally than the crew roster, we have a block buffer. So you got a card block buffer, and that defines the structure of the ship. The other thing we could do is we could have a hull, and the hull has a block buffer, but that doesn't make a ton of sense to me. Ugh. Alignment issues are real. Be aligned. All right, so we got a block buffer. Let's finish setting this up. Oh, you're being annoying because of this. Kind of wish I could turn the snapping off. I bet there's a button that just turns snapping off here. Or lets me control it more precisely. Yeah, because I can't work like this. There we go. Now we got ads. Just gonna hang out. The ads run. I'm like reading a little bit about array versus span usage. Yeah, I guess the main difference is that the enumerator of the span is on the stack, while the enumerator of the array is on the heap. I guess the span object itself is on the stack too. That's tempting. It's similar. It's similar to our other process. So maybe we end up doing a block buffer as a class, because you just have the block buffer. It can clean itself up because it could own its own iMemory. So we could have it be disposable. If we do some cool stuff with memory storage for the chunk, we could share that improvement with the block buffer. Kind of tempted. I'm kind of tempted to organize it like the chunk. I know the simpler thing is to just make it an array and call it a day. It's a little weird to have the iMemory on the same thing as the thing holding the memory, but I think it's fine. I think it's fine. We might need to think of a different way of doing this for a dynamic buffer, though, because this is for a static buffer. Because it's a buffer based on the total volume of the ship, whether it's the actual volume or the allowed volume, or the yeah, the maximum allowed, or if it's the actual being used, as far as like if you don't have a, if you're only using 3 decks instead of 5 decks, do you need to store the other 5 decks? Probably not. But that's an optimization we can put into the editing system. I guess we don't really need span for this though. Maybe we do the simple thing and just be done with it. It is a nice way to constrain read versus write access, and it could be a way of we could have a version system eventually. That'd be a lot easier to do with span. All right, yeah, let's just ape our let's just mimic our chunk structure essentially. I don't know if we necessarily need an item count though, because of how we're doing this a little differently. Maybe we do. So a block buffer, if we do it this way, it shouldn't be a struct. If we do it as a class, we could have a base class buffer and then the block part. No, that doesn't make sense either. So we have a block buffer. We would need to have we would need, I don't know whether it would be public or not or private or whatever, but we'd need to have an iMemory owner. And the iMemory owner would be for a block. Let's look at iMemory owner. I think we're getting too complicated with this. I don't think we need to rent the memory like this. I don't love the idea of cleaning up the memory in the same place that we allocate it. Like, I don't love the idea of having storing the memory on the same object that has the memory owner, that is the memory owner, but I guess that's fine. That's actually, I think, a totally fine pattern. I wonder how expensive .memory is. Like, do I want to store the memory separately? Probably not, right? I just store the memory owner by itself. An array pool could be used here. We're not really going to... Well, actually, we might create and destroy these frequently. Well, no, not frequently. Yeah, I think I'm overdoing this. I think I'm overthinking this, but that's kind of our brand, so... I mean, it's a nice way because we're probably going to be loading. We're probably going to be having ships loading and unloading and loading and unloading. Like, not all the time, but like quite a lot. I guess it doesn't matter. On the scale of like an application program, it's not going to be fast enough where we really need an array pool. Let's 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 implement the simplest thing first, which is an array. And you know, if we don't like it, and if we do some research and we decide that we want to go more hardcore and do like an array pool or memory thing or whatever, I think it's fine. I think it's fine to just do this. Just use an array. I don't always need to go off the deep end. The reason we went with the memory span thing for the chunks was because the chunks don't know what memory is in it. So having to be able to get the span and reinterpret the data in the memory is good for the chunk, but for a buffer, I don't think it makes any sense. In which case, we can just have this. We can go back to having this be a struct because it's just going to be a reference to an array with maybe some additional information in it. Let's just do that. Let's just do it simple. I don't care. I'm convincing myself as much as I'm trying to convince myself more than I'm trying to convince you, but you know. Let's use a system array. Actually, we don't say array, we just say block. Call it blocks. We do need to store the dimensions of it. So we could say something like vector3i dimensions. Probably call it bounds. So we'd have a block and we'd have a bounds. It could also be a size, but whatever. Kind of like bounds. Do it like this, right? If we're just trying to pass in the capacity to this. You mean zero length allocation? Oh, I'm an idiot. Lengths would be bounds. It would be bounds dot x. You don't have a dot x? Oh, it's capital. Yeah, that makes sense. Plus bounds dot y time. Oh, you would need. It's bounds dot y. How do I tell this thing its capacity? Like, forgot. I haven't done one of these in forever. It's just x times y times z, isn't it? Bounds dot x times bounds dot y times bounds dot z. Yeah. We want to order it in a different. We want to order it differently to maybe minimize padding. I feel like structs respect a literal layout maybe a little too much. Because yeah, we'd put the vector first and then the reference to the block after. That's fine. That should only be 128 bits for the block buffer entry. And that's a good size for a component. That's kind of like, I think that's like the sweet spot size for a component. It's 128 bits. Oh, this is an interesting analysis. It considers that bounds declares the implicit positional property di.ecs.blockbuffer.bounds that is never accessed. This may result in unnecessary state being captured in block buffer instances and participating in implicit equals to string implementations. Interesting. No, I guess we can't compare these. Yeah, that's a good point. We actually can't really compare these, can we? That's fine. We shouldn't need to do. Maybe we don't make this a record struct. Yeah. We don't need all of the built-in fancy record stuff. It is going to affect our ability to describe or to do the print values thing. I wonder what that'll look like. Let's add that to a component. Or let's add that to an entity and see what that looks like. Yeah, here's the simplest possible way we could implement a static buffer. Dynamic buffer would probably just be a list. That would probably be the simplest way to implement a dynamic buffer. Let's do that with the crew buffer. So let's say make a new one of these. This one would have an integer length. Well, actually, no, we don't need an integer length because it's dynamic. It's going to be a dynamic buffer. So this would only have public entity ID. Entity ID, crew. Kind of playing fast and loose with the collective noun use here. Because I like to have just the individual element and then buffer rather than this. We could just call this an entity buffer and not a crew buffer. But I like crew buffer because it very clearly, you know, says what it is. We could call this the crew buffer dot roster. Maybe we don't use the word buffer for everything. Maybe that's like calling things. I mean, it's kind of stupid when you call something a list. He says, as he has a chunk list object that he refers to, which is named poorly. I do admit that. I'm tempted to rename the chunk list like component chunks. Because that's what it is. It's all the chunks for a given component on an archetype, admittedly. But it's the chunks of a component. Because yeah, I don't like naming things by like its organization, by like its type. Or in this case, I'm naming it based off of a parameter. Like this whole thing is named chunk list because it has a list of chunks inside it. I don't love that. Why was I doing this though? Because I'm storing an array of these. So it would just be, oh yeah, so higher up I'm storing chunk lists on each archetype. And if this is called component chunks, then what is that called? Is that called components chunks? So yeah, I guess that's not a great way of doing that. Theron Keen. How's it going? How's the game coming? It's good. We've got a fancy entity component system that we've knocked up. We're trying to implement some buffers for some stuff. Let's forget about the crew buffer right now. Let's work on the block buffer, because the block buffer is the thing we want to focus on. What happened here? Oh, block buffer must be a valid unmanaged type with all fields of unmanaged type at any level of nesting. Right. So we can't put an array on a buffer. How are you doing? I thought there was a thing I was ignoring here, so we can't do this. Can we do an iMemory? We do an iMemory owner of block. How do we do this? We say memory pool. Let me go to the chunk list. The chunk list is where we do this. We say memory pool.shared.rent. Okay. We're going to rent bounds.x times bounds.y times bounds.z. Does this meet our restriction? Does this meet our... It does not. Because an iMemory owner is not... Oof. So we need like a buffer allocator. You're good. You and your kid are working on your first 3D project in Godot to learn 3D stuff before we try working on an actual game. Awesome. I'm gonna try to control my language in case there's a kid around. You've made several 2D projects in one kind of game that was more or less done. Feels like we're about ready for a real game. Yeah, thank you, Anonymous Gifter. Thank you so much for the tier 1 sub gifted to Theron Keen. Lol, no, he's 18. Okay, well then. It's too late for him. In terms of, you know, managing his language. Okay, well, thank you. Thank you for letting me know that. That's really cool, though. That's a really cool thing to work on. To work on with your kid. That's really great. Yeah, I would love to see some of these projects. No pressure. We have a Discord that has like a share your work channel, which is like the only channel that's used on the Discord. But I ask everyone if they're interested in the project, and if they're doing their own thing and they want to share their works with us. I love seeing that stuff because that's really exciting. I did my first Godot 3D game back in August. It was like a 72-hour game jam, and I'm really happy with it. I was kind of hesitant about Godot in 3D, but I like it. You're enjoying modeling and animating much more than you expected. Been learning low poly modeling and Blockbench. Oh, awesome! For me, that was pixel art. I know that's not 3D, but like as far as the things that like I'm required to do that I have no experience doing, for me it was pixel art. I was like way more into that than I thought I would be, which is good because I need to do a lot of it for this game. It's gonna be a lot of this kind of thing. Post a couple of low poly things. Yeah, please do. We're always happy to have people join the community over there. All right, so we've run into a hitch. We've run into a bit of a hitch. Oh man, this is going to lead to a whole rabbit hole. I'm thinking about all the things that we need to think about. So, if a buffer is only able to store, how does a chunk work? A chunk is a struct, but it doesn't only contain unmanaged. Well, hold on. Let me see. Let me see if this suffices. I know we can't do this because we need to hold on to the iMemory. But can we do this? Does this at least fulfill our requirements for what a record struct is? I'm thinking the answer is no, because this is a memory is not unmanaged. Yeah, okay. So how are we gonna do this then? Um, this kind of throws a big wrench into my plans for the buffer system, where buffers are components. Because components need to be unmanaged entirely, and memory is not. It's unfortunate. I'm like doing some research. I don't think we can just put a span on here. I don't think that's gonna work. Yeah, we can't do that. Okay, what are we gonna do? How are we gonna do this? Close your browser? No worries. All right, so there's a couple of things we could do here. We could have like a buffer store. We could have like a storehouse of some kind that contains the buffer. And then the buffer component would just be a reference to that. You need to get that. If you wanted to process the buffer, you need to like basically go get the memory. I mean, that's kind of okay. So I want there to be some kind of component so that we can tell that we have a buffer. And I want information on that component. I mean, it's not the worst if we just end up having something like this, like some kind of like just instead of the being able to put the memory and stuff directly on here, you put something like int like buffer index. I don't know, whatever. Doesn't matter. Yeah, that. And then you use this to get to the actual buffer, which would be stored like centrally somewhere. That kind of sucks. That kind of sucks. Um, because then we would have to store. We would need a storage thing for each kind of buffer, unless we do the same trick that we use with chunk, where we say we store everything in byte form and we reinterpret it when we need it, which we could do. That's actually not the worst. And then we would just have one like buffer, block buffer, like a buffer pool, basically. Oh, if we have a buffer pool, that means we should just implement our own iMemory owner, right? Like our own memory pool sort of instance. Hmm. Hmm. We implement some kind of central storage for that stuff. Then we just have an index into here. Probably make it an ID. Well, we probably want an ID system of some kind, like cuz let's see. What are the cases in which like a buffer gets recycled or reused and we restore it? Like that's the only trick is that here's the thing that I'm scared of. Here's the thing I'm scared of implementing it this way. We're quickly heading into command buffer territory. And I know that also has the word buffer in it, but it means something totally different, which is like if we have an entity that references a buffer, and then that entity dies, and it's the person who owns the buffer, or it's the entity that, like, primarily is interested in that buffer, then the problem is we need to free up that buffer. Like, we need to know that that entity has died. Oh, we can work around this. I think we can work around this. I mean, a system would know if an entity has a buffer. And so if we end up destroying an entity with a buffer, well, what if a system operates on an entity and the system doesn't know that that entity has a buffer because it's not relevant to that system's processing? Then you have to do a thing where either you have to like check every single entity that you're going to destroy if it has a buffer and do some kind of cleanup process, or you still do that, but you do it in like a command buffer phase where you're processing instructions that have been like submitted. We might end up having to do a command buffer for a number of reasons, in which case this would be easy, but I don't want to go straight to doing a command buffer just to implement this kind of buffer system. Ugh. Okay, this is more difficult than I anticipated. What do we want to do? What do we want to do? I don't mind the idea of having like a buffer pool sort of thing. I do want the component to be particular about what kind of buffer it is, but it could still refer to like a generic underlying structure. But also, it could not. I don't think there's a problem where where we would store these separately, where we like have a thing that only stores block buffers, and we have a thing that only stores like, I don't know, crew buffers, which would be like crew rosters. We could do that. That's more straightforward. And then we would know we wouldn't need to do any of this casting stuff. Which makes sense because we actually can't really do the same tricks. Well, we can kind of do the same tricks. Because like the block itself is not a component. The buffer is the component, the block buffer. And in this case, it's not even the buffer. It's going to be like a buffer reference. That kind of sucks. This would need to be like game.world. Like get next buffer index. We would need to make the buffer. So just adding a component of a block buffer to an entity would involve a lot of work. Because like, let's say you're adding this buffer, this block buffer component. Maybe it references an already existing buffer. Like maybe you're another entity and you're also interested in this buffer. I don't think we can do that. I think we need to have like exclusive ownership. So a buffer belongs to the entity onto which its component has been added, but it needs to be stored somewhere else. So that sucks. So this would be like a block buffer key. Or something. Like it would be a way of getting into the block buffer. So we could just say like index, blockbuffer.index, and then we need to refer to some third-party structure that stores the buffers. But when we add a component that has a block buffer, I guess we need to handle this in the world, on the game world side somehow. So game world. So it wouldn't be add component. It would be like add buffer. You'd have like a separate workflow for when you add a buffer to an entity. the buffer thing would still be a component. Like the reference to the buffer would still be a component. But when you wanted to add it, you would need to say add buffer. Oh, this sucks. Okay. I'm tempted to just have one buffer store. And then so a buffer block, like a block buffer like this could have something like, it could have methods thing here. It could have like a public span block. So it'd have a block span blocks, and then it would be, but this would be, so to get this, you would need to do something like game.world.buffers index. So you would do that, and then you would say, so when we transfer something to a span, what does that look like? So you do that by saying well, that's for the cast, so we don't necessarily need to do the cast. But we do if it's stored in byte form, which I kind of want to do. I kind of want to just have one thing of buffers and not worry about adding buffer structures for every type of buffer. Okay. Okay. Chunk.buffer.span. So we go to the chunk. So we just call the memory and get span. Okay, so we'd say something like this. So we'd say game.world.buffers.span. It would be game.world.buffers. So we'd get the memory. So we get the memory, we say whatever, we say world buffers.span, and then we pass that in as the parameter of the cast. Assuming we just have one of these. So it would be memory marshal. So this would be read write. Is that the right structure? Memory marshal.cast. Oh, then I pass in the add you. Oh, do I have to say what we're casting from? Yeah, we say from to. Okay. So we say byte, then we say block. And then so we say memory marshal.cast, so we're casting from byte to block. And we say gameworld.buffers.index.span. So this would be essentially how it looks. Excuse me. Actually, we probably wouldn't call directly into game world buffers. We'd probably call in like call in like this. Say like get buffer. We probably want a buffer ID just to prevent any kind of issues like we have with entity ID, where like if something gets destroyed, I don't know. Game world get buffer index dot span. It would be like this. So that'd be like read write. You'd have the similar thing of like read only span. So we could do something like this. And this would be okay. The thing that I'm most concerned about is still managing what happens to the buffer when the entity that owns it dies. Well, we have a destroy entity function. So we could just say, oh God, we probably, no, F. F. What we probably need is a dictionary that maps an entity ID to its buffer. That's probably what you need to do, rather than having the index directly on the block buffer like this. You would probably access it using the entity ID, in which case this would be static. So this would be static. This would also be static. This would be read only, entity ID, entity ID. Honestly, we could cut out the middleman here and not tie this to the buffer struct. The bounds thing here would be pretty crucial in terms of the information needed to process it. So in a way, this is actually very similar to our chunk structure. We could almost have a generic buffer. But we want it to be specific because we want to make these components, and components have intention. There is intention encoded directly into a component. So like a block buffer, even if its underlying structure is the same as like a crew buffer or like, I don't know, like a whatever other kind of buffer you can think of, having it be the block buffer is important because systems are going to be like, I want to operate on entities with block buffers. That's what I want to do. So you can't just store them generically. We can store them generically here on the world, which is the world is going to be the one that gets the buffer for us. And then the bounds is crucial for letting us know how to process this. Okay, so this will probably work. I think we're going to need to put a component on an entity that has any buffer, or we just need to have a dictionary on the world that like matches entity IDs to their buffers. Because actually, an entity might have more than one buffer. Because like a ship might have a block buffer and a crew buffer. Oh god, in which case, get buffer, you can't just pass an entity ID in. Oh, I'm so upset. I'm so upset right now. Because if an entity has more than one buffer, you would need to know what kind of buffer it is. We could have some kind of buffer lookup the same way we have our component flag system. But that's horrible. It's horrible. Maybe we really do need a buffer ID on the block. Maybe we do. Maybe we need that. So we have like a public integer. It probably won't be an integer. It would probably be like a buffer ID. Should be like very similar to an entity ID, except in its intention. You just call it buffer ID. Probably need to have something like that. We'd need to get this when we construct it. It would need to be like game.world.get next buffer ID. All of this would be a lot simpler if we had command buffers and like, I mean, not simpler, but we could handle a lot of this stuff if we were like queuing up commands and then executing them at specific times in the frame. But we're not going to do that yet because that's really complicated and is a prelude to like multi-threading. Because we're just going to run system by system in order. We don't care. I don't think it matters that much. If it matters at all, we'll just move the simulation off of the main thread. I think that by itself would be like huge. Okay, so we need a buffer ID system. And that's just to protect against references that maybe don't get cleaned up. Because entity IDs are unable to clean up all the references to themselves. It's similarly, buffer IDs might be the same way. Like I can see a world where like a crew member, like let's say a crew member is trying to make a decision about where he wants to go. From a pathfinding standpoint, we can handle that, whatever. But like from like a goal evaluation standpoint, like if a crew member is running around and is like wants to check something about the ship that it's on, or not even a crew member, just anyone on the ship, it could be an enemy. They're like, you know, can I or should I do this thing? Should I like go to this block basically? Or like maybe it just wants information about the block that it's currently in, which is actually the most common case. It's going to need to be able to get a span of the blocks, look for the block that it's in, and then see what's up with that block. And you know, either that's an entity check if the block is an entity, but in this case we're not going to do blocks as entities. So because we're not going to do that, that means that that crew member needs to be able to get the block buffer from the ship it's on and then look at that block. But it doesn't actually need to retain a reference to the block buffer. It would be efficient so that we're not jumping around, but it's not necessary. So maybe a full buffer ID is actually too much. A full buffer ID might be too much. Let's start simple. Let's not make a buffer ID. Let's just have an index. And then you don't pass in the entity ID. You make this not static. And you pass in your index. This might be private. Nobody should need to know about our index here. It's something that just should exist. Maybe we just pass it in. In which case we just say index. So it depends on who's responsible for creating the block buffer. It's probably going to be the world. So that should be fine. And this will be world get buffer index. That span. Okay, this could work. This could work. This ended up being a lot more complicated than I was expecting, but as it should be. It's always going to be more complicated than I'm expecting. Might end up having a shorter stream today. I had a meeting run late and I need to do some laundry, so we might end up wrapping up in the next like 20 minutes. That's cool. We're in the middle of our week as far as, our streaming schedule. We stream Tuesday to Saturday. I'm trying to do 3-hour streams most days, but sometimes it just doesn't work out. All right, so let's try to do some stuff in the world. So we have get next entity ID, which is interesting. So that we probably also want like a get next buffer ID as well. We'll probably utilize a similar system as our entity system for the buffers. So that we can just probably pretty much lift and copy. But what we do need to do is, so we have an add component function, right? Maybe we do add component and then we just have a check on the type flag of like, and we just, because the problem is you could easily call add component right now. Oh wait, add component takes a value. maybe it is add buffer ID or add buffer. Because a buffer ID or adding a buffer just requires a bounds. Unless we just want to use a default amount for simulating the space around the ship as well. Maybe we just make that one of the utility values right now is just like maximum. It'd be like max ship bounds. Ship boundaries have an extent, right? Like it's an odd number, right? Because I want to have a 0, 0. The real question is if I'm going to allow for off-center rotations. Vector 3 can't be a constant, right? That's not how that works. Did I decide 15, 15, 5? Yeah, compile time constant. Okay, but you can be public static. Time to go to the source. What are we currently using? Currently we're using 886 to -8, -8, -1. But the build extent is 1 shorter than that. This is a little awkward, this whole deal of this. And this is because I made it positive numbers. And I did this so that it goes from 5 to 0. But it really doesn't need to go from 5 to 0. It just helps a little bit with the translation. But it's a little more awkward to represent. It's easier to just say like 3. Because then it would just span from +3 to -3. Then you could just say, you could just take the number and add the max ship extent .z to get the right number. Let's start with that, and then if we hate that, like if that drives us insane, we'll just do something about it. So this should be 8, 8, 3. Let's look at this get buffer function, if nothing else. So it would be a public function. So it would go around here, public. What does it return? It returns a memory. Oh shoot, memory is type specific. That's fine. We can say this. We can say get buffer integer index where t is unmanaged. Well, no, it would be byte. You return the byte. You just get the byte. But we don't. Oh, we don't have to do it this way. So we could actually. We could turn this into like get read only buffer, and we could actually cut out the this thing. I don't know. I kind of like doing it this way. It doesn't need to be type aware. And that's right because we're going to be storing these generically in one store, in one pool. And so how are we going to store this? So it's going to be like I guess it'll just be an array. So it'll be an array. No, it'd be a list. It'll be a list of. So it'll be here. It'll be a private read only list of memory byte. And this would be called buffers. And that's what we'll use for buffers. Or do we store it like this? Do we store it like I memory owner byte? Maybe we need to implement iMemory owner or implement a memory pool or just use an existing memory pool like array pool or something. I don't know. I don't know. Oh well. Sorry, this was kind of a rambling stream. I think we've dug into a pretty significant issue, but I'm gonna do some thinking about it, and we'll come back tomorrow and we'll tackle this thing. And sooner than later, we'll have buffers of blocks, and we can start refactoring our auto tiler and our ship editor tool in C#. No, thank you, thank you, Keen. Really appreciate you hanging out here today. I hope your projects go well. And yeah, we're gonna be back tomorrow, approximately the same time, hopefully a little earlier. I had to start pretty late, which is why we're cutting, which is also, cutting into our time. We're ending early and we started late, which is not ideal, but hopefully tomorrow we'll get the full time in. And yeah, I'm confident that we can have this sorted out by the weekend here. But yeah, thank you all so much for watching. I hope you have a great rest of your day, and I'll see you next time. I said I'll see you next time. Sound system, music, source of all music.